Inductance. There are two types of inductance. One is self-inductance and the other is mutual inductance. Self-inductance, which has been previously discussed about, I have emphasized about it in details. Self-inductance is the voltage induced in the coil, in the same coil. The voltage induced in the same coil when the current is changing in the same coil. When there is a variation of current in the coil, voltage induced in the same coil is called as self-inductance. What is mutual inductance? Mutual inductance is the voltage induced in the nearby coil. The coil nearby the coil carrying current. Mutual inductance is the voltage induced in the coil nearby the coil carrying current. Now you are calling them as primary coil and secondary coil. The coil which is carrying current is called as primary coil, and the coil which is nearby, it is called as secondary coil. That means it is closely associated with the coil. And as we know, when the current is flowing in the coil, magnetic flux is induced in it. This is a magnetic flux. Magnetic lines of force passing through the coil. And this magnetic flux also spread out nearby coil. This magnetic flux spread out the nearby area surface. That is why we see that some of the magnetic lines of force circulating through the nearby coil. These circulated magnetic lines of force produces or induces magnetic flux in the neighboring coil as well as. Where there is a current in the primary coil, there you see magnetic flux in the primary coil as well as secondary coil, but magnetic flux are only from this coil. When the current changes, when the current is varying, magnetic flux also varies. Magnetic flux varies in this coil as well as this coil. The variation of magnetic flux in this coil induces voltage, that is called as self-inductance. And the variation of magnetic flux in the secondary coil induces voltage, that is also called as the voltage induced in the secondary coil. This induced voltage, the voltage does induced in the primary coil as well as secondary coil. There we see the EMF is induced, the AMF is induced. We can call this E1 as the EMF here, E2 as an EMF. Both these EMF or voltage induced will oppose the variation of current in the primary coil. Both will oppose. That is according to the Lenz's law. Anything which is induced, the magnetic induced voltage, either in the same coil or in the secondary coil, these two induced voltage and as well as the induced current will oppose the variation of current in the primary coil. So this is the concept about the mutual induction. There are two coils which are close with each other. I will explain in detail what is that. The same two coils I have taken here. This is a primary coil, this is a secondary coil. Here, the primary coil, the current I said if there is a variation of current, once if the current increases and the other is current decreases, what will happen? So, any increase in current, here, definitely there is a voltage induced in the secondary coil as well as primary coil. Voltage induced in this is not shown, it is there, but voltage induced in this secondary coil is E2 and it has its own current, induced current. So let us call this as I1 as current in the primary coil and I2 is the induced current in the secondary coil. The symbols, E2 is called as induced voltage in the secondary coil. I2 is the induced current in the secondary coil. It is due to variation of magnetic flux due to variation of current in the primary coil. If the current increases in this coil, see the direction of the induced current in the secondary coil, same direction. That means whatever the induction here, both will oppose the increase in current in the primary coil. That will tend to decrease what is increasing. That is called resistance or opposition to the primary coil. And if the current is decreasing, this is either decrease or increase, then what is that voltage is induced and its own current. Look at that. The direction of the induced current in the secondary coil, it is opposite to the source current, that is I1 in the primary current. Opposite. So this trend will oppose the decrease in current in the primary coil. So induced voltage. The induced voltage, let us call it as E1, it is not indicated, and induced voltage is called as E2. It is self-induced, it is mutually induced voltage, the difference. So this is observable if there are two coils close to each other. In that case, we come across both self-inductance and mutual inductance in this case. So, we are talking about what is a mutual inductance. Let us go for the derivation of mutual inductance, just like the self-inductance. So, derivation means always begin with what is that, the concept is basically what is that, any flux in the coil, any flux induced in the coil is proportional to the current. In this mutual inductance, only one coil is what is that, source of current, carrying current, it is induced. So we are talking about the current flowing through, the source of current flowing through the coil. Here this is what the basic concept. Total flux produced in the coil is directly proportional to the source of current. And I want to calculate the magnetic flux in the secondary coil only, because mutual inductance, already taught the self-inductance. What is the mutual is the flux, magnetic flux in the secondary coil. So total magnetic flux in the secondary coil is N equals 2, pi equals pi 2. 2 stands for secondary coil, 1 stands for primary coil. Symbols. It is pi 2 is flux, that is flux by single turn. N2 means there are N2 number of turns in the coil. Total flux in the secondary coil is this. Is directly proportional to I. What is I? Current is source of current in the primary coil. There is no source of current here, it is induced. So it is proportional to the current flowing through the primary coil. So it is proportional to the primary coil, current in the primary coil, I1. So proportional means if you remove proportionality sign, it becomes equals constant. M2 it is known as coefficient of mutual inductance. M2 is called as coefficient of mutual inductance in the secondary coil by primary coil. M2 stands for coefficient of mutual inductance in the secondary coil by the primary coil. That is what we want mathematical equation for M2. Now let us call this as equation 1. Let us calculate this in terms of mathematical equation. What is the total flux in the secondary coil? Total flux in the secondary coil. This is thus basic definition for the flux in the coil for one term, AB cos theta. Here theta equals 0 since A and B in the same direction. So theta equals AB. A means area of cross section of the coil. What coil I am talking about? Secondary coil. Area of cross section of the secondary coil. And B is a magnetic field produced. Magnetic field produced due to current I1. Here magnetic field produced by the coil 1, primary coil. D1 stands for magnetic field produced by the primary coil, because magnetic field is produced by only primary coil. The same intensity we are using here. D1. And N2 is the number of turns in the secondary coil only, total. So it is the magnetic flux in the secondary coil. You can write this magnetic field in terms of current. Since magnetic field is a function of, already the derivation we have, that is function of number of turns and current strength. Here coil 1, this is coil 1, coil 2, number of turns in the coil 1 and number of current in the coil 1. Here number of turns per unit length, N1 small n1, and the current in the primary coil. So this will induce magnetic field, that is B1. So B1 we can write in terms of these quantities. So replacing B1 by this, finally we have this equation. And substitute for N1, what is N1? It is N1 by N1 about the coil 1, number of turns in the coil 1 and length of the coil 1, number of turns per unit length, that is N1. Put this into the equation, we get this equation. And finally we have this equation 2. Equation 1 and 2, look at that. Let's say calculated. Left hand sides are equal. Equate the right hand sides. And I1 is there, cancel. Right, M2 is equal to remaining. Mathematical expression or mathematical equation for mutual conductance. So where is the mutual conductance in the secondary coil? The mutual conductance is a property explained in details like similar self-inductance. This is inertia, of course. Electrical inertia in the secondary coil. Mutual inductance is a function of these parameters, depends on the geometry of these coils. That is, mutual inductance is directly depends on number of turns N1 and N2 in both primary coil and secondary coil, and it is also dependent on the area of the secondary coil, not depending on the area of the primary coil, but inversely proportional to the length of the coil L1. So mutual inductance is a function of these parameters. Mu naught is a magnetic permeability in the space vacuum. If you replace the space, any material of magnetic property, that is iron like this, we replace as mu for iron, it will increase further. So instead of vacuum, if you take any magnetic material, the material which supports magnetic field, example iron, it will further increase. So this is about the definition for mutual inductance. And if you take the coils in this fashion, two coils in this fashion, here are two solenoids, that is two concentric solenoids. What is concentric? one solenoid is enclosed in the other one, just like two concentric cylinders, two concentric solenoids, inner solenoid and outer solenoid. Let us call the outer solenoid as a primary coil, inner as a secondary coil. Inner is smaller in size, outer is bigger in size. But both of them have same length, solenoids, L. If the current is flowing in the outer current, that is outer coil, and any variation in the current induces voltage in the inner coil, inner solenoid, that is voltage induced in the inner solenoid is U2 and the current thus produced is I2, induced current in the inner coil. So this is induced voltage, induced current in the inner solenoid. It is a current flowing through outer solenoid. So this same thing you can apply here. Any variation of current, there is a mutual inductance. Mutual inductance induced in the inner coil. The voltage induced in the inner coil, that is secondary coil, due to variation of magnetic flux or variation of current. That is again the coefficient of mutual inductance in this case, M2 or M, the same equation applicable. That is mu naught number of turns outer, number of turns inner, and area of cross section of the inner solenoid, in area of cross section of the inner solenoid, and length remains same. L1, L2 remains same. You can take as L, length of the solenoid, two concentric solenoids. So this is the mutual coefficient of mutual induction in this case. This is the formula. Now you have taken the similar coils like what you have taken already here, similar coils. The difference here, I have taken DC current, the increase, decrease. Let us apply AC power to the primary coil. You are applying DC current to the primary coil. AC power to the primary coil, as you know, AC itself is a variable current. It varies in magnitude and direction as well. AC current varies in magnitude and direction as well. Magnitude means it increase and decrease. AC means there are series of cycles. Each cycle is increase and decrease, variation of increase and decrease of current. So this variation of current, AC power, there is a variation of current. That variation of current produces variation of flux in itself as well as variation of flux in the secondary coil. This variation of flux in the secondary coil induces voltage, induced voltage. It is called as AC voltage because the supply is AC power, AC current. And the current is AC current, induced current is also AC current. If this circuit is connected to a load, this current is consumed in the circuit. Yes. Now we see that we have both, what is that? Self-inductance and mutual inductance. As you know, variation is AC current or DC variation, of course. And this variation means in the primary coil, what is the variation means if the current increases, energy is stored up in the primary coil. If current decreases, energy will come out. That is, it will give out the energy if the current is decreases. Now in AC we have seen that a cycle of AC is always cycle of increase and decrease, a repeated cycle. While increasing current, energy store up, while decreasing current, energy give back the energy. That is why in every cycle of AC, we see that the energy is stored up while increasing, and what the energy is stored up in increasing, will give back while the current is decreasing. Here increase as well as decrease. Cycle of increase, decrease. This cycle of every cycle what is compensated. Increase in energy, decrease in energy. So that is taking place. So this primary coil it is called as, what is that? Energy stored up in the primary coil. Energy stored up in the magnetic field in primary coil. But in secondary coil, what is that? Energy is transferred from the primary coil to the secondary coil due to mutual inductance. What happens? Energy transfer, energy in the power of electric power. Power transfer. Energy transfer from the primary to the secondary due to mutual inductance. But energy stored up in the primary coil due to self-inductance. Remember the difference. Self-inductance stores up the energy in the magnetic field. And mutual inductance transfer the energy from one coil to other coil in the magnetic field. Look at the difference. So because of this concept, what is that? Induced EMF or induced current is AC current. We are using this concept in the construction of transformers. As we know, the transformers of two types. That is step up transformer and step down transformer. Step up means increase the voltage from primary to the secondary. We can increase the voltage from the primary coil to the secondary coil if increase N2. If N2 is greater than N1, it will, what is that? What the voltage induced is more than what the voltage applied. Step up the voltage. The stepping up is important in the transmission of current over a long distance. And in step down, difference is this N2 is less than N1. N1 number of turns in the primary coils is more than the N2. The voltage what you apply and what is voltage induced. So this induced voltage is less than the voltage applied. Step down. It is there at the time, at the point where the distribution taking place. Electric power distribution. So this is the concept of using AC power. So only in case of AC power, these transformers are very useful for construction of step up and step down transformers. So the idea, what is the idea? Mutual inductance is the idea we are using for the transfer of energy. There is no touch between this but closely associated. Transfer of energy from primary coil to the secondary coil in the magnetic field. It is possible. And storage of energy in the primary coil in the magnetic field. But what is stored up will give back because always way increase and decreasing. That is getting compensated, of course. So this is about the transformers. And the unit of mutual inductance is similar to self-inductance, Henry unit. So you will say mathematical equation. Here, this is what we are using. Magnetic flux is equal to M2 into I1. And the variation of, when there is a variation of current in the primary coil, there is a variation of magnetic flux in the secondary coil. This is what I am talking about. This variation of magnetic flux is called as voltage induced minus C2, opposite direction, equals M2 into di by. So rate of change of current in the primary coil gives the rate of change of magnetic flux. It is the induced voltage E2. It is E2. M2 is the magnetic, it is coefficient of magnetic mutual inductance. So definition is, so when di by dt is equal to 1, M2 equals E2. Can you definition? What is the mutual inductance? If the mutual inductance is 1 Henry, the current, what is that? 1 Henry means the E2 means the voltage induced in the secondary, that is, it means voltage induced in the secondary coil is 1 volt by the variation of unit rate of current in the secondary primary coil. When the current of 1 ampere in 1 second changes in the primary coil. When there is a unit variation of current in the primary coil and voltage produced in the secondary coil is called as coefficient of mutual inductance in Henry. If you have 2 Henry means 2 volt is induced in the secondary coil by change in unit rate of current in the primary coil. 3 volt, that is 3 Henry, 3 volt is induced in the secondary coil. So, if voltage induced in the secondary coil, then there is a variation of current in the primary coil or unit rate. So, this is a unit similar to the self-inductance. Self-inductance in the same coil, mutual inductance in the neighboring coil. So, with this we have completed. Thank you very much.